Hello, everyone. Today we're going to be going over the computer science first unplugged activities. So, computer science, really well known to be used with computers and technologies, but right now, during this time, right, a lot of people don't have access to technology at their fingertips. So what we're going to be doing is using on-paper activities to not only give people more access to learning computer science, but also for people to take a break from the screen, especially since everyone's going through an unhealthy amount of screen time. Our first activity is going to be networking a neighborhood. Some people use map programs every day. Finding the best path from one place to another is a tricky problem that can be solved with the help of computer science. Try to connect all of the buildings in a town. Use as few spaces as possible. So let's start here. How does a map app determine the best way to get you from one place to another? Roads aren't always straight, and they can connect each other in many different ways. For long trips, there can be thousands of ways to go. How do you know which one is best? Let's look at a real example of this kind of problem. The phone lines in this town were blown down by a windstorm. The whole town is disconnected from the internet. The mayor wants to install new high-speed internet for everyone. She's asking you to help design a single network that connects all the buildings to each other. To help network cost less, it should use as few segments of cable as possible. So let's start with the instructions. You can start anywhere. Think about which paths between buildings will keep your cost low. So focus on cost low. Low cost means a shorter path. Connecting buildings by filling in segments with a pencil or small counters. Dry beans work great. So if you have a pencil, any pencil works. You can also use counters, coins even. Check to make sure you can trace the path from any building to every other building. And count the number of segments you used, that is your total length. Can you find a way to connect the building using fewer segments? So there are many ways to go about this problem. The first idea that comes to mind is labeling the length between each path, within each path. So chances are we're probably not going to use 5, but it depends. We'll have to really take a look at what is best in our plan. So first we can really think of how to connect the shortest connection between each building. So from each area, we can call this a node where there's an intersection between many different paths. We can call these nodes. And we can look for the lowest number, the lowest distance, the shortest distance between one node to another. If we pay attention to this house, we can see that 2 is the lowest node. So let's first lightly circle here. So we don't finalize our procedure at the beginning. We should always try to plan things out. And then once we find the best way to go through the plan, then we finally color through each square, each rectangle here. So from this house, 2 is the shortest. From this house, we have this is the shortest, so 2 and 2 are equal. This building, 2 is the shortest. This building, 1 is the shortest. Same thing for this building. This building, 2 is the shortest. This building, 2 and 2 are the shortest. And this building, the 3s are the shortest. So what this tells us is the shortest amount of distance that one node has to the other based off the node. So these are going to be the main paths that we'll be looking at. So again, our instructions say to make sure that we can trace a path from any building to every other building, which means that we do not necessarily need to connect this building to this building directly. And that's actually impossible because we have nodes that block, or houses that block our transport from one to another. But since we circled the shortest distance between each node, we can actually focus mainly on these paths within our procedure. So when we really look at this, we have to have this 2 because this is the shortest distance here. So we can probably finalize this one. We can also finalize this 2 because if we didn't use this 2, we would either have to have 2 3s or a 3 to connect here. We would have to use a 3, which is larger than 2, so it's not the best path to use here. So 2 is the lowest here, 2 is the lowest here. So we would probably finalize these 2. And even though we circled 2 3s here, we can really just choose 1. The reason why is because in order to access this building, it doesn't need to have the shortest distance from this building to here. It just needs to have the shortest amount of distance connecting all of the nodes together. Because again, we're looking for phone lines, not the shortest walking distance. So really our problem here is focusing on the shortest amount of phone lines that we have to use. So 2, 2, use one of these 3s. It really doesn't matter here because if we use this 3, this house would be still connected to this house because of this path. And the same thing with this 3, this path. And all other houses based from this intersection, this path or this path. Now, if we look at the 2s, if we use this 2 and this 2, even though 2 plus 2 is greater than 3, we are using length of 4 to connect 3 nodes or 3 houses together, compared to using 3 and 2, which is 5, to connect 3 houses together. So using 2 and 2 is going to be the shortest way to go about this problem, to create the shortest length. This one is obviously going to be the lowest here, and we can actually use this 2 or this 2 here to make the shortest length. The reason is because if we used this 2, it's still connected to this house, which is connected to this house, which is going to be connected with both of these houses, and those houses are connected to the rest of the houses. So let's actually fill in the blocks. Now, I'm not sure if this is the shortest path, but this is a good way that you can repeat the logic in order to find the shortest path between different areas. And this is really important in computer science if you want to find the fastest and most efficient way to do something. If something takes more time and you can reach the goal with a shorter path or a shorter amount of time, then you found the best way and the most efficient way to spend your time to get to a certain goal. But in this case, we're looking through a neighborhood and finding the shortest distance for phone lines to go from all of the houses to all of the houses. So let's count this up here. We have 2 plus 1 plus 2, 5, plus 2 is 7, 9, 12, 14. So our total distance here is going to be 14. Hopefully there's an answer here. I'm not completely sure. Okay. Now we can do a reflection here. Think about how you solved this problem. What was difficult? How would you explain how you solved it to someone else? So, what was difficult, really, when you really look at it here, is that it's a tangled mess. It looks really complicated. When you don't prioritize and focus on what's different between each path, it can be really hard to choose which path is best for our problem here. Writing the numbers here are going to allow us to distinguish between each path, find which path is most efficient. For example, if we used this 4 path instead of this 2 path, and then we would have an increased length of 2. But we wouldn't focus on the number if we did not label each path length. If we didn't look at the shortest path from one house to another, we wouldn't be able to go through and find the shortest path. How I would explain this to someone, how would you explain how you solved it to someone else, is 3 steps. 1 is label the length of each path. 2, choose the shortest path from one node to another. And 3, determine if any of the paths are unnecessary. For example, this path and this path. These are unnecessary. Or if you chose this path, then these are unnecessary because they perform the same function, connecting one node or one house to another. If you wanted to create roads that allow people to go from one place to another instead of phone lines, then yes, actually you would want to use all of these paths. Why? Because it would create the shortest amount of distance. If you wanted to create the shortest amount of distance from this house, or this building to this building, yeah, use this 3 path. Because this is going to have a distance of 3 versus 5. And maybe you would use this 5 path instead of this 3 and 2 path because maybe this is a highway. Maybe you want to create the fastest way, and this looks like a city or something, to go from one place to another. It would take less time to go here than to drive slowly in the neighborhoods. The speed limits in neighborhoods are much lower than the highway. So maybe you would use this 5 path. But again, we did have to identify the problem. The problem is to find the shortest distance connecting all of the buildings to create phone lines, not to create roads. And that's what allows us to use one path instead of both paths. Okay, so that's activity 1. If there are any questions, or if you found a different way to solve these problems, feel free to share it in the comments. And hopefully this was helpful.